for the for this VC. I always switch CV, VC, venture capital.
Prashant is still, yeah. Yeah.
Thanks for giving us a little break from technical stuff, talking about money a bit. Now we'll get back to it. All right, so it's recording good. Yeah, I think let's give a minute or two to chill down. Whoever wants to sit, take a seat. Whoever wants to not take a seat. So, what was the last topic we talked about and finished on it? Yeah, it's good. I knew you would see the hint behind me. So, who can tell me, where's the mic? Who can tell me the difference between internal and external messages, just to recap? So, to be sure that we're on the same page. Who? One hand, I need one hand. You want to try? Anybody from Rasa? No? You want to try to explain the difference? Okay. Maybe something.
Alright, so you can consider that there are two ecosystems. One is the Dawn itself and one is the Ethereum. And now you are trying to communicate within two systems. So whatever the calls you make, the API calls you make, externally, those are the external messages, basically. And whatever the contract calls happens within the Dawn ecosystem itself, those are the internal messages, right? So that's a very generalized way how you can say it.
Which of them is bringing money?
The internal ones right now.
And external ones have no money?
They do, depends on the use case.
They don't have money. They never have money.
Yeah,
External
exactly.
messages bring no money. They can't even pay for themselves. You have to pay for them. So, and you have this free amount of money to actually to decide if you want to pay for them or not. Cool. Thank you very much. Can I have this mic? Because I feel like this one is falling apart. I'm just afraid to break it, you know. All right. So let's go to the next slide then. And this one is sweet. Who is coming from the EVM background? Nice. So there's a few things that I already briefly covered, but it might be worth mentioning in compare tone to EVM. So one of them is contract interact by sending messages to each other. Calls between smart contracts are asynchronous and not atomic. This is exactly what we were discussing with this whiteboard thing, that they're asynchronous. So you send it and you don't know when, you cannot await it, you know, like in Node.js or something. So third one, your smart contract cannot run getter methods on other contracts. It's basically a consequence of the second one, yeah? And then contracts has to pay the rent for its own chain storage, and everything is stored in self. So this is the brief summary. And now we get to the very sweet spot that I love this one, but I very often see the developers on Tom who are kind of ignoring, not ignoring, but because they didn't get this concept, they are actually, they use Tom to build contracts and apps all the way, old style, the way it was built on Ethereum. Like we talked that blockchain, the Bitcoin is basically money. Ethereum is a programmable money and a database. And Ton is bit data. So you can see on the left side, you can see the Ethereum contract. So this is Jeton's architecture. We're going to now compare the Jeton's architecture of Ethereum and Ton. So in Ethereum, a Jeton is one contract. It's basically you have a database of addresses, so you have address, balance, address, balance, address, balance, and that's how you know you calculate all of this, and that's how you know that a certain emission of the Jeton is like 100 millions or something. In Ton, and the problem with this, what's the problem? Why don't we do the same? The problem is that what happens if there is 1 million users. It's not even that this contract can be called just 1,000 times a month, but just the fact that there's an unlimited amount of users, like imagine how expensive, Rahul, you were talking about, it will get expensive, it will get very expensive to store this data. Like you mentioned, that the more data you put in there, the more it's expensive. So basically this is why there's another downside of this. Because the processing of this contract is not only expensive, it's also heavy. So in Ton, there's a block, and then inside of block there's shards, and inside of shards there's transactions. So basically, your transaction, single transaction of interacting with this smart contract might be considered as a shard. So it will basically not 1, 2, 3. Am I correct, bro? Maybe this one is not.
No, that's working fine.
It's okay, yeah?
Yeah.
Okay, so basically, your transaction can be treated as a whole shard. So it will take longer to process, it will be more expensive, and it will just get worse over time. So in Ton, we don't store this data inside of one contract. So in Ton, and this is best practice, you can still build a contract that will store the whole table with balances, but it just makes no sense. So the concept, and this is coming back to the standard, this is the standard. So in Ton, jeton, so token or jeton, is like n plus 1 contract. So where n is amount of holders. So how does it work in practice? We have one master contract, this one. Yeah, I tried to make it as a red, but not sure if you see it. So we have master contract. And the cool thing is that once you want to mint a jeton, you are asking master contract to mint it to a certain address. And you do one transaction. You just say mint, and you say where to mint. But this master is actually deploying another contract. So it's deploying another contract that is, and it says like admin of this contract is going to be you, because your address is done that. And it is minting this amount of jetons to this contract. So basically, the minter always knows the emission. It knows what is the total amount of jetons, but it doesn't know what is the particular balance of this user. But what it can do, it can calculate, it can know what is the address of the user. So whenever you want to ask, what is the jeton wallet of Aman, what is jeton wallet of certain jeton? And the master, the minter can calculate that. I'm going to talk about this a bit later. But okay, it's clear how it happens when we go to master and ask it to mint. But what happens if this wallet wants to send money to another wallet without minting them? It's not minting money. You know what is mint, right? You create it. So without creating it, we just want to send it somewhere. And the cool thing is that the wallet deploys another wallet. So the master can deploy a wallet, and the wallet can also deploy another wallet. And basically, yes, this contract will be deployed by another contract that you don't control. But in jeton logic, you are the administrator. So only you can transfer those jetons, no one else. So basically, if for example, you never minted the jetons with master, so you basically don't have a wallet. So when someone will send you money, it will deploy a wallet for you. If someone will just transfer it, if you already have the wallet, it will just send you the money. So basically, it is like this. But how is it possible? So we have there is a code, right? So there is code of wallet, and master has this code inside of his storage. You remember we said that code is stored in the cell. So master has a cell in the storage that is holding the tree of cells that is holding the code. And the wallet also has this code. So basically, in this structure, every entity has the wallet code in his memory. And this is why it's possible to deploy the contract by sending message. And here, deploy the contract by sending message. And I already actually spoiled the sweetest part, that in Ton, we deploy contracts by sending messages. So basically, I will talk about this in the next step, but I find it amazingly beautiful. And it's not that obvious from the first glance that if you don't read the whole documentation website, it wasn't that obvious for me. That's exactly why I kind of bring it up. So, give me a second. I need to switch the slide. How is it possible? How do we deploy? How deploy process works in Ton? Come on. Okay, if you could just switch to next. So, we have a cell with a code. We have a cell with a storage, and the storage. So at any point of time, you can get what is the storage data, and you can get what is the code of the contract. But there is also the initial data in the storage. So,
That responded now.
yeah, no, one deck. 5. It was 5 seconds, and now it's like
Shall I do it?
one deck. It will now respond again. So basically, your code, so for example, you program the contract that your code is taking number, the counter number, then the address of administrator. So your data structure is like integer and then address. So when you run the contract first time, if there is no data written, it will fail because there is no data in the storage. So once you first time run the contract, there must be some data already. So this is called initial state. So initial state of the contract is certain data that we put there from the beginning. So let's say for the counter it would be like 0, and then it would be 0 address. So this will be your initial state, and there will be a code. And the cool thing that if you take the cell with the data, initial data, and the cell with the code, and you take a hash from those two, you get the address of your contract. So we know the address of the contract before we deploy it to the network. So it's called deterministic addresses. And basically, we are able to, and they are unique because like this data, like initial state of data and the code, they must be unique. So you always have to have some certain something in the initial data that is unique to the contract. You know, if someone will do the same data and the same code, basically it will be the same contract and the same address. That's why we'll talk about this on Q&A. I guess this is something new for you, but we'll talk about this on Q&A. But what happens next? Let me try. Yeah. What happens next? So we calculated the address of the contract. And now what do? We create a transaction of sending the message with this initial data, with the code. We send this message to the address that we calculated. So basically this transaction, we throw it into validator. The TVM is catching up. It looks that it's not yet deployed. It deploys it and it runs the code of the contract against the initial data. So the first run of the contract happens immediately. And then from this moment it's deployed. So you basically have, of course, because it's a message, it's a transaction, you have to provide some money. So you have to throw in some money together with this message. So your contract will immediately have gas to function. I find it very beautiful. If you want, we can run a Q&A about that. I think this would make sense. Who has questions?
So basically, coming back to the Jeton's architecture, we have seen that yeah, cool. So we have seen that the master contract basically holds all the template contracts, so that these template contracts are executed whenever you try to make a call, like minting a token. Okay, so then this master contract has a template for that particular thing, and which is exercise, right? but like if we see what are the building blocks of tone, like are they the jetons itself?
I didn't understand the question, sorry.
Okay, so what I mean to see is like if we see the Ethereum, so the building block of Ethereum is Ether, right? So Ether in total comprises of the Ethereum. Same we have in the Bitcoin, like Satoshis are there, the building blocks, right?
Okay.
So 10 is to power 8 Satoshis is what one Bitcoin is, right? So do we have something in the Ton?
Yeah, of course. So one ton is like 9 zeros of nanos. There's so one.
Cool.
There are decimals, yeah.
Exactly. So firstly, like to program the Ton, we have to know that so that we can put actual value how much exact token we want to mint. Like, is it
Okay.
taken directly by the master? So that's the question.
So let's distinguish native coin, ton coin, and the jetons. So let's separate those because jetons is just numbers.
Got it.
It's basically just you have on the master you have the number of emission. So everything that master knows, it is the metadata. It knows the emission, what is the total supply, and it knows the code of the wallet. Maybe something else, but I can't remember right now. But that's it. That's enough.
Got it.
So this is one thing that we have to separate native coin and the jetons. Did I get your question right? That you're asking how it happens that you buy jetons with tons, or
No, not exactly. So let's say I have to write a contract where I have to mint 5 tons, right?
you cannot mint tons.
Exactly, right?
Yeah.
So
Well, not anymore. Pavel
Yeah.
and Nikolai minted all that, and they didn't even call me.
So let's say I'm building a coin on top of Tom and I want to mint that coin.
Mark jeton.
Right. So I have to input the number in the jetons itself, right? So let's say if I want to build 5, maybe like 10 coin, like let's say I name the coin as 10 and like I now mint 5 10, but I have to put the number in the jetons itself. That's what I write in the documentation, and I have to input like something like 10 raised to power 12. 1 multiplied by 10 raised to power 12. I have to put that much of zeros, and then only it's able to mint that much amount of.
Yeah, it's like there is a. If you go, you can mint your jeton right now. You can go to the minter. I think it's ton.org/minter, or it's like minter.ton.org. You can mint it and play around with the decimals, but it's important to not. It's important to put the decimals because if you make it whole, like just like 10,000, that's it, then you won't be able to. There's a certain. You're gonna face this issue with the commissions because
Right.
yeah, I've seen one guy who deployed it. I couldn't remember the case in particular, but you would have to play around with the decimals. But in general, jeton is just numbers on the. Yeah, it's just numbers on the cell.
Right.
Maybe I didn't understand your question still, but there is certainly a need to figure out the decimals game because it depends on your business case. It depends on how you're going to use it. So help me to understand your question. Maybe if we still.
No worries. Like I was just trying to highlight that
Okay.
there is a need to specify the decimals. We
But-
need to be aware of it.
Yeah. But I would say right now I would have to spend like a few minutes on the presentation to check this out because of course like that's why we have Stack Overflow. If you don't know something, you just go there. But
Correct.
by the way, do you know that there is a Stack Overflow for Tom? Answers.tom.org. So you can go and ask their questions, and it looks just like Stack Overflow, but Stack Overflow banned us. So like there was a lot of questions
So
there.
you create an in-house farm basically.
Huh? Yeah, we made our own like in-house Stack Overflow.
Cool. And also, how exactly the worker contracts work?
Which one?
Worker contracts.
Locker.
Worker.
Worker.
Yeah, WORKER.
Worker contract. What is this?
So basically, like let's suppose I have two contracts created, and I used one contract to call the another contract, which does all of the job, right? So my second contract is called as a worker contract. My first contract is called as a primary contract.
Yeah, like this particular model, we call it master and client contract. But I think I understand what you mean. But with worker contract, this would be a client contract in this model.
Yeah.
Right. So like the master would be the primary contract
Right.
in your terminology.
Right.
And the wallet would be the worker contract. So they both work just like normal contracts. It's like, by the way, important to know that every wallet contract knows the master. So
Exactly.
it only accepts the messages on transfer. No, yeah, wait, on burn, because no, burn is actually sent or vice versa. But anyways, ask the question because I just figure out the terminology now. So what's the question?
Cool. So basically, in this cell architecture, like how exactly that worker contract works, that was just my question. That's it.
How exactly the worker contract works in terms of cells?
Yeah.
Just like normal contract. So basically, I'm not sure I understand how I can answer that, but it's like they're not dependent, you know. They are not connected. They are not tied to each other. These are two independent contracts, but they are connected just by the fact that this address is provided here as a master address. So if you find some wallet and you want to figure out who minted this wallet, who is master, you can see it here. So they have different data structure, but in general, they are independent contracts. They are just connected logically. They are not. This is not some kind of a model that two contracts are like a couple now. It's like it's independent contracts.
Correct. Yeah. Also, the other thing is like, is the signer different from the contract?
Who?
The signer, the contract with the signer, like the authentication, message authentication.
Authentication.
Yeah. Signing any message.
Look, it doesn't matter who signed the message to deploy this contract.
Okay.
Because in the concept of jetons, it doesn't matter. Obviously, if you check who deployed it, it will be master. So it's not you.
No, perfect.
If you ask, like let's say, if you ask master to mint some jetons for you, it's not like you deploy the wallet. It's master deploying the wallet for you. So technically, owner of this wallet is master. But the logic of jetons works in a way that it. So how do you usually you use your wallet like TonHub or TonKeeper to ask the minter to mint some jetons, and basically the wallet will have your address of your the wallet contract here, the client contract here will have the address of your TonHub wallet. Maybe let me get back to the white paper. So not white paper, the whiteboard. For the rest of the guys, does it make sense what we're talking about? Right? You're not lost? Where's the market? So, one more time. We have a master. We have a master contract. We have a client contract. Word wallet. I will not use word wallet, I will use word client because we also have a wallet. It's TonHub, TonKeeper, keeper. And then, for example, we have, let's put it another way. This is also client, but it's not yet, like, it doesn't exist yet. So, you with your wallet, you're asking master to mint certain jetons, but it cannot mint those jetons on your wallet because jetons it's not native coin, it's numbers. So it has to write somewhere, how many jetons to give you. It's just a number. It has to write like 5. So here on master, there can be different logic. So for example, you can hear, for example, you say, I will mint 5 jetons for him if he will provide 5 tones, 5 native coins. It will check the value of the message, how much it sent, and if yes, it will mint jetons for him. If no, it will just return the money and say, ciao. But if it actually decides to mint it, it is going to, so let's briefly describe what master knows. It knows the total supply. And you remember there is a memory cell, right? And this is what memory cell knows. It's written like total supply. It also knows the owner. No, total supply, that's it. It's only one number. It knows the owner, like administrator of this master. It has the wallet code. And I think that's it. That's enough for us to understand. I think there was something fourth, some fourth value, but I forgot it. So basically, this is what this contract knows. And now once it deploys, put it this way. Once it deploys the client, the wallet, let's describe what wallet knows. It knows the balance. It knows the owner, but the owner will be this address. So this address will be recorded as the owner there. Then it will know the master address, and then it will know the balance owner master address, and it will know the wallet code. It will know the wallet code. So basically, this is your wallet, but it's not the same contract as your real wallet. And that's why in your Ton Hub or Ton Keeper, you can just see like your balances on this jeton, but how is possible? So for example, you have your account on mobile app Ton Hub. You have your wallet. And Ton Hub knows that there is like 300 jetons, like good ones, scam ones, whatever. And master, according to the most recent standard, master has a getter method. It's important. It has a getter method called get wallet addresses. I don't remember the name, but basically, Ton Hub is asking every single master it knows about. It is giving this getter method. It is giving it. Yeah, I think that's exactly how it works. It is giving it your address of your real wallet, and it gets this address. It will return you this address. So basically, Ton Hub is able to first figure out your wallet address for your wallet, and second, why is it possible? Because we can determine it. We know in the beginning we know the balance was 0. We know the owner was you. We know the master address, this, and we know the wallet code, it's static. So it's very unique. So this will be, we can calculate it easily.
So what I mean over here is like doing account abstraction is not possible in this case, right?
Doing what?
Account abstraction. So let me show.
Sure. Yeah, you can, so everyone's using.
That's right. So we have the wallet, right? And this wallet sends a request to the master node,
Yeah.
right? To mint X Zedons in exchange of Y dons, right?
Okay. Sorry, X jetons?
In exchange of Y dons.
Oh, okay, yeah.
Right? So like not hard cutting any number. So
Usually it's not made here. Usually there is an ICO contract,
correct.
which is stored on the money,
Yeah.
but it's fine.
Yeah. Just to simplify it, like,
Yeah.
okay, so now here, when I do this, so I, as the owner of this contract, I have to sign that message
Okay.
to be sent to the master node, right? And that master itself checks with its existing wallet code, like
Yeah.
whether it's validated or not.
Yeah.
And if it's validated, it will then proceed the process, otherwise it will stop here, right?
What do you mean by validated?
The transaction is validated or not. Like, let's say I have to mint the X jetons, so whether I'm giving Y jetons or less than Y jetons, as you say, right?
Oh, you mean like it just checks how much money?
Exactly. Like,
Okay.
it isn't it's a malicious call or something like that. So that's where the validation happens.
If when you, for example, want to mint, there can be some check that, for example,
Correct.
sometimes
Logic
the
check.
total supply can be fixed, so you cannot mint anymore.
Right.
So it will not do it. But in general, there is nothing malicious can happen. It's
Yeah.
basically either yes or no. It's like you check if if he sent enough money, and you check if you still can mint more.
Correct.
So that nothing malicious can happen by now.
So now on this side, I have signed this transaction myself,
Yeah.
right? Now, what I mean by the account abstraction is where I can differentiate the contract and the signer. So they both don't exist together, right? So what I can do is to make this contract sign, I can write another contract which will be the signer of this contract, which is this.
Okay.
Yeah, so this is account abstraction.
Look, one of your accounts doesn't matter how it was signed. Someone has to sign transaction, of course, but one of the accounts will send the message to master. So basically, this one will be owning this wallet.
Yeah, that is defined.
Not this one.
Of course, this one will be owning the wallet, but I'm saying that.
Actually, it's wrong. It's wrong because this one can ask master for whom he wants to mint.
Yeah, so
According
it
to the
can
structure
be,
of the message,
Yeah.
you can actually specify that you're minting not for yourself, you're
Correct.
minting
You
for
are
someone
making
else.
for someone else. So whatever the wallet is, that's not in the regards right now. What in the regards is that whether I can do this abstraction or not.
I think I promise you to discuss this with you personally. I'm not sure that
Okay.
everyone is on the same page with your question.
Got it.
And we will
Perfect.
definitely get back to this topic once we maybe finish.
Sure.
Yeah, thanks for bringing up the question, but I think it will be right if we, for now, abstract from the accounts abstraction. So, yeah. Sorry guys, anybody else has any questions to this? Let me recap. So, we went through the, we went through the, jeton structure, the deploy process. It's a magic that you could, it's a deterministic addresses, so we can actually know the address before we even deploy the contract. And second one, and the last one is that the deploy process itself, when we send a message to the address that is not yet even exist yet. So anybody has questions through this context? Or it's that clear? Oh, yeah, 1 second.
So that means, do I have to pay rent for holding jeton?
Yes. Because when jeton is actually a simple contract. So basically, when let me go back to the. No way. Okay, just went off. So basically, sorry. So basically, this is just a normal contract. That's actually a good question. When you want to transfer some money, so this is your wallet, you own this client wallet, right? This is your virtual wallet of this jeton, let's say, and this is your real wallet where you own the keys, because you don't own the keys from this wallet. It's just a number, and you just have a right to do something with it. If you want to transfer some money, you would send a transaction to here, and this transaction would have to have some tokens with it. So this is exactly how you're going to pay to maintain this contract. It is going to be part of the commission. It's not big, so you will not feel it in terms of money, but it is still there. And once you do that, you want to send some money from here to someone else. You deploy his wallet, if it doesn't exist yet. And the cool part is, as you can see, we don't touch the minter. We don't touch the master. We just subtract some amount here, and we add it here. And the commission is not taken from jeton. You don't pay commissions in jeton. You always pay commission in the native coin, in tokens. So yes, you have to pay for the rent of your client contract, and you're going to pay it in tokens, not in jetons. Anybody else has a question?
Okay.
Yeah, sure. It's okay. Any question?
So you mentioned about that issue in the architecture, right? The Ethereum one.
Yeah.
If you have 1 million users, right? So how is that actually addressed here in terms of storage? That was the issue.
Okay. Because this is number of contracts.
Yes. That's
You don't store the balances here. So the master is lightweight. It only knows how much, 3 values. And this one is lightweight. It only knows its balance and other things. So even 1 billion users, they might affect the validators' work if we don't have enough validators. But they will not affect the speed of transaction and the cost of transaction, because the amount of data stored here doesn't increase. And if you have 1 billion users, let me try to connect back to this thing, because I don't know why it disconnected. Wait.
Refresh.
Okay. Seems like I connected. Review slide. Yeah, so here we're back to this graph. So here you have, in tone we call it unbounded structure. So unbounded means there is no certain bound how many users you can have. So you can have like 3 million or 5 million. Here you store them all in one contract. And here it is kind of like, it is distributed. All this data is distributed. Every contract knows only its balance. So the data is not stored in one contract. Does it answer your question? Or not yet?
But yeah, kind of. But this data is still there. It's distributed, right?
Sorry?
The data is still there.
Yeah.
Okay.
But the problem with Ethereum is not that the blockchain cannot store so much data. The problem is that the contract will become slow and expensive. And that's the problem. And we solved this. This is the problem we're solving with this. We solved the problem that now our contracts are lightning fast, and we believe in, we understand that our network is ready to get 1 billion users.
So it's really the bottleneck problem that we are solving with that particular contract.
Bottleneck?
Yeah, it's that one particular contract might become busy.
Yeah.
That's what we are solving.
Exactly.
So we have actor model basically, that's why.
Sorry?
We have an actor model basically. So each contract is an actor.
Yeah. I mean, that's a Tom. In Tom, like we spoke about this before, that Tom has actor model. So it's asynchronous because of the, you can say there's three ways to apply that. First, tone is actor model. Second, tone is asynchronous. And third, you cannot call another get methods from another contract because you can only go one way. So all these three things they're saying about the same.
It's a DHE basically.
DH.
Direct acyclic graphs, directional acyclic graphs.
I'm not sure. I might be, but
like the fact of blockchain is. So
I'm
you
just
can
not sure
only-
about the terminology.
So every sequence can, every transaction can be gone through one sequence.
Yeah, so at the end of the day, to see certain transaction chain, we take the state of the blockchain from multiple blocks, and we check from each block from where to where it went, and what was it related to, you know? So it's basically the task for the explorers, not for developers. Developers have to keep in mind that this is extra model. Okay, so let's have two more questions from new people who didn't ask any single question today. Anybody? Okay, if not, then let's jump to next slide. Okay, so this is the last chapter of our today's lecture. And here we are going to prepare for the actual tomorrow's coding session. So, how does it feel so far? You already know a lot about Tone now. Even if you didn't know nothing when you just came here, you already pretty much know the architecture, you know basic concepts, you even know how jetons work. If I knew that someone can explain me that in one day, when I came to my first hackathon, I would kill for that. So someone will explain me that. But so you guys are lucky just pointing it out. But now let's talk more about like practical stuff. I think we had to go through the theoretical part. So once you face code, you will actually understand with what bigger concepts are standing behind it. So it will be easier for you to start programming more efficiently. So, how many of you ever used TypeScript? What are some other languages we have here? Like, but no, so we don't say Solidity. We like.
Fancy.
No. Basically, TypeScript is actually language that is the most popular in Tone to actually operate contracts. And we're going to talk about this much more now. So basically, we have to do three things on the life cycle of the contract. We have to compile it, we have to test it, and we have to deploy it. And now we're going to, thank you very much. Oh, it's for me? Wow, that's too much. What I switched. Sorry guys. I hope I have this. Yeah. So, we use fancy, but fancy is not the code that is executed on the TVM. We need bytecode to execute on TVM.
That's converted to fast.
Yeah. So, yeah, Wasm, that's exactly what is operating the bytecode, like creating the bytecode. Huh?
The website.
Yeah, the WebAssembly. And, but the language between fancy and the bytecode, there is fifth. And fifth, this is language you pray God you will never encounter. So you
Assembly
definitely.
basic.
Huh?
The assembly language.
No. Fifth is not assembly language. It is a language, and I have to tell you, core team is writing all the tests in fifth. And when I interact with them and work on some projects, I don't like this because I hate I don't just hate writing Fifth. I'm not able, I know some basics to write it, but I hate to even read it because it's quite complicated. If you ever think that Fancy is complicated, imagine that someone is writing contracts on Fifth. It's possible to write a whole contract on Fifth, but it is complete disaster. That's why we have Fancy. And basically, there's a JavaScript library that is using WebAssembly to actually compile Fancy into Fifth and then Fifth into the bytecode. So we don't care about this on a daily basis, but I'm outlining this because it's important for you to know if you ever hear of Fifth and you're not sure what it is. It is a middle language between Fancy and the bytecode, and as I said, pray God you will never have to deal with it. And as one of the greatest developers in Ton, I'm literally not the greatest developer in Ton. Maybe I can explain certain things in a simple way, but I still love to hang out with the best. I love to learn from them. They are the best, and one of them answered my question. It's even on YouTube video. I asked him, what's the best way to deal with Fifth? And he said, the best way to deal with Fifth is not to use Fifth. That's what you need to remember. But anyways, I'm not trying to bully Fifth, but just saying as it is. So there's a library from CGS, and this library is using WebAssembly to compile. It is maintained by Tom Tech, I believe, and it is available under Tom Community. You will not probably need to install it manually. It will be usually installed with a certain frameworks or templates that you're going to use. And then second stage, as you remember, compile, test, deploy. For testing, we're going to use Sandbox. Sandbox is also developed by the same guy, Narek Abogan. Hi Narek. I'm recording this, so I will actually show him that. So, great guy, probably the smartest Armenian guy I know. So he and his team, they wrote the Sandbox Sandbox library, and the Sandbox is actually able to emulate contracts. So you can emulate, it actually even emulates the blockchain. So it's all like locally, it emulates the interaction.
Running a test.
Yeah, basically, no. What is the power of Sandbox? It's emulating the running of contracts, and you're able to run get methods and everything, but on top of it, you're using Jest to write in tests. So basically, you are triggering certain behaviors of contract that you want, and then you use Jest to actually expect certain results. And this is basically the test. So it's very important. It's a very important part that you will have to. You're probably going to spend 50% of time if you're going to code contracts, 50-50. So 50 is writing tests, and 50 is maybe even more for writing tests. Because in web, you can, HTML, you can change the design, you can refresh the page, and you see the result. When you write fancy code, how do you test it? Do you want to deploy it every time? How do you debug it then? It's not possible. So basically, you would need certain local environment to emulate it. So basically, you write some logic, you write some tests, so you say, create an instance of this contract, and send message into it, and then run get method to see how the state changes. And then you write the expect something. So basically, you're writing the test of how it's supposed to behave. And then you run the test, and you can see that fancy code compiles, runs through that, and you can see the results. So one of the greatest developers, Dan Volkov, you can find one of his videos on our platform, Ton & Co. There is a course on boarding, and he has a video of how to interact between web and contract, web app and contract. And he told me one important thing is like 2 well-tested contracts locally, well-tested locally, if you have tests for them, they will greatly work together on chain. So you don't even need to have a chain tests locally. So you should carefully write tests to avoid redeployment of the contract and spending some money on testnet or the mainnet. Obviously, I don't think I have this in presentation, but we have two nets, right? We have mainnet and we have testnet, so we don't have to pay money to, like, every time we test around it. And who knows how to get test coins? Testnet coins, okay. Oh, I think I was sending you some, right? So you would need to get testnet coins, and there is a Telegram chatbot where you can get them. Like you can get 2 coins per 15 minutes or something like that. Do you still have them? Did you already spend all the coins?
No. Actually, after every year, we start looking to coins. We are collecting it. Right now, I have 150.
Okay. But oh no, okay. There were times when testnet was working very bad, and people were literally buying testnet coins with real coins in chat. Really, like they were saying, I need this coin, so I need testnet coin. And you could pay 10 real-time coins for testnet coin. Okay, so test is fine. Deploy. Obviously, deploy, we're just going to sign a message and send this transaction into the blockchain. So we're going to use the normal wallet. So you will need to have your testnet coins on your testnet wallet. So obviously for testnet, we're using other wallets, testnet wallet. All right, another important thing, who's using VS Code? Who's using IntelliJ? Okay, other people IntelliJ? No? Okay, so there's a very cool extension for Fancy Highlight. It was also developed by Dan Kovler from Tonwell's team, my lovely colleague.
We have also developed.
You do what?
We have also developed syntax highlighter for the.
Is it like independent, separate?
Yeah.
For VS Code?
For our.
Ah, okay, but okay. Come on, it's not working. Yeah, and the last thing, the last slide for today, that I encourage you to try before you come tomorrow. Try to run npm create Tom. This is a major command that will generate you a sample project. Sorry?
Actually, I have when I run that command, I have a blueprint. The blueprint is
Yes.
that model is not installing properly.
We can debug it tomorrow. We can try around. Like, actually, npm create Tom is using blueprint under the hood. So this is a command that I encourage everyone to try running. If you have some issues, I have a connection with developers, so we can actually provide them with feedback how the code starts out of the box. So let me briefly. Oh, now it's actually switching. Yeah? Didn't switch before. So the plan. Yeah?
Sorry? Video is not? Okay. It's recording.
No, it's recording. It's just low battery. Thank you very much. So, what we're going to do tomorrow? We're going to have a hands-on example. I will maybe sit here. I don't know, maybe we will sit all together somehow so you could see the code. Or maybe...
We can connect it directly on the projector itself.
Yeah, maybe I will just... But we will see. We will come up with some plan how to do it. Maybe we will do it online, in some online. So I would sit, I would be with mic programming, and you would actually watch my screen on your screen. This might be a great way to solve it. Because I would really want you to also code with me and try it to code with me tomorrow. And basically, that's it for now, but let me run through a few introductions, like a few QR codes. As I said, like the visit cards that I gave you, this is, and you can scan it here. This is a QR code to our platform, where we do onboarding. We help guys to get onboarded in Tone. We help guys to get certain support, like technically on the business side, on the marketing side, and we tend to try to help them to raise money as well. And in the very soon future, we're going to have a launchpad as well. So you could launch your jeton on our launchpad and change the world, or change your world at least. So basically, that's a great place to socialize for developers and for founders. And my personal opinion is that socializing is one of the best ways to learn Tone. If you just read documentation, a lot of times you will find yourself hitting the wall with your head. And you should find the smart ways to socialize about Tone. So you could make meetups, just locally talk about this, because you should validate your knowledge very fast. You should say what you think, how it works, so others who know a bit more, they can actually correct you if you're wrong. So the longer you keep it inside and don't put it into practice, don't talk about this with someone else, the longer you will learn. If you want to learn fast, talk about it, socialize it. On Tone & Co, we provide live rooms where you can socialize, and there's Q&A sessions with me, with other smart guys, Narek Abovyan, Dan Volkov, like these guys are attending those as well. And yeah, this is something of how it looks. You could get some mentors there as well. And this is the Tone Dev chat. This is one of the great way to get immediate support from best developers in chat. So top developers in Tone, they're hanging out in this chat. You should definitely scan the QR code and join this. This is worth it. And yeah, and like probably the official Dorahacks chat. Do you want the dev chat?
Yeah, official chat and all of us are.
Okay. So this is dev chat. Everyone scanned who wanted? Okay. And then this is the Dorahacks chat. So if you want to know any news about stuff, you should join this one. And that's pretty much it, guys. We can either run a series of Q&A, or maybe everyone has asked the questions they wanted. I really appreciate your attention. I'm honestly surprised how many people we still have. So you guys are not scared of this, and you did run away home. I really appreciate this. I really hope to first have fun tomorrow while coding and writing tests. And second, I really hope that I will see your faces very often in these live rooms, maybe on next hackathons that are gonna come. And if some of you master a certain topic in Tone, like for example, you master jetons or some edge cases of jetons, like guys here, they're going to present tomorrow. They do the whole online EDA. So it's like, if you have certain project and topic, just text me directly. We'll arrange, maybe you can even speak on our online meetups. Because this is a great way to validate your knowledge, to get involved in more and more things in Tone. This is the fastest way to take the best out of Tone. All right, that's it.
Yeah, thank you so much everyone for coming in. If you have anything, then like this is the right time to ask anything in that. And Mark, I would want you to kind of share that what's the plan for tomorrow.